Alright, boys and girls, welcome back to the drive-thru. Special Friday edition. Special shout-out to words that start with the letter F. Thank you. What does it say up there? 26. Let's look at 26 from last night before we go into helping you on today's. Okay, so in number 26, we're given some functions. So f of x is a trinomial, 2x squared plus x minus 3, okay? And g of x, gia, is x minus 1, and 26 wants g over f of x, and that's the same thing as g of x, gia, over x, f of x. So that is x minus 1 over 2x squared plus x minus 3. Now, at first glance, you think, cool, done. Okay? And you are like, this is fine. This is the answer. It's just not the best answer, and it's not the answer that's going to show up in your multiple choice section of your ACT. It's going to be disguised as a more simple answer, okay? So the question becomes, can we do what to the bottom? Can we factor it? I don't know if that's what you said or not, but that is the question. And then, in order to factor the bottom, we would have to do this thing which is called the AC method, which we learned. We're looking for two numbers that multiply to be -6 and add to be +1. And then we would take those numbers, we would do a riddle, we would split the middle, and then we would factor by grouping. It would be complex, and I'm going to do it for you. But might be a better way, okay? Because really what we're trying to do is figure out if this thing turns into x minus 1 times something. Because if it turns into x minus 1 times something, then we'll be able to cancel them. Are you following me on that? So we're going to use a different strategy. How could we figure out if x minus 1, I know it's weird because it's on top. How can we figure out if x minus 1 was a factor of this? We could use synthetic division. Do you remember that? So in synthetic division, what does this minus 1 turn into? It turns into a +1, okay? Come on. And then what we do is we write down a 2, a 1, because there's a 1 in front of here, and a -3. And then do you guys remember how to do this by any chance? You start by bringing down this 2, and then what's the strategy now? Multiply and add. Sweet. Our remainder is 0, so it is factorable. So that means x minus 1 does go into this, and what do we have left? What does this thing mean down here? 2x plus 3. Now, first of all, if I was having a bad day, you guys totally just pumped me up, because that's awesome. You just remembered so many different things that we've learned, and nothing is more important to me than your retention. Well, that's not true. The most important thing to me is that you guys are happy, and I help you guys understand how to be happy. I'll just have a really, like, 1 out of a million percentage of help in your life that way. That's the most important thing, okay? But from a math standpoint, I don't want to teach you anything that you forget, because all we've done there is just checked the boxes and gone through the motions. So, super pumped that you guys remembered how to do that in synthetic division. I'll be 1 second. All right, so we found out that 2x plus 3 and x, so here's what we think. Here's what I think. I think that we can write this as x minus 1 on the top, and then on the bottom, x minus 1 times 2x plus 3. Now, I'm a little worried to see if I did that right. So I'm just going to FOIL to check real quick. What is x times 2x? 2x squared. That's a good start. X times 3? 3x. -1 times 2x? -2x. -1 times 3? negative 3. Does this thing equal this thing? Yes, it does. So we did it right. So now, do you understand that? Kind of? So now we can do this. Bam! And that's why on your answer key, you see it written as 1 over 2x plus 3. Okay? Now, what is x not allowed to be? Well, we should look over here for this. What is x not allowed to be? Well, it's not allowed to have 0 in the denominator. So x is not allowed to be 1, right? Because you put in a 1 for x, you get a 0 on the bottom. Now, to figure out the other one, we know that 2x plus 3 is not allowed to be 0, which means 2x is not allowed to be negative 3, and then x is not allowed to be negative 3 halves. So that's the other piece of our domain. This, oh dear. This is our domain. And that was a great question, okay? Now, I promised you I'd go back to that, and Skylar, I am going to answer your question. So, let me explain it a different way, Feng Yi. This might help you more. I'm just redoing this problem in red. We had x minus 1 over 2x squared plus 1x minus 3. Okay. I'm looking for two numbers that multiply to be AC, so they multiply to be 6, and add to be positive 1. What are those numbers? Sorry, negative 6, and add to be positive 1. What are those numbers? Positive 3 and negative 2. So what we do is we do a riddle to split the middle. This is how I taught you how to do this way back in the first quarter. You call it 2x squared plus 3x minus 2x minus 3. Do you remember ever doing that? Doing a riddle to split up the middle? And now, do you remember what we do next? We factor by grouping. So what number goes into the first side? X. And you factor out a negative 1 from the second side. And then you turn that into x minus 1 times 2x plus 3. Do you see that's the same thing we got using synthetic division? Okay, so those are your two options on how to do that. That's tough stuff. Okay, so now we're going to go into today's work. Yes, that's right. Okay, we had a great follow-up question. So it's regarding this step right here. And the question is, when you cross that out, why was the answer 1 over 2x plus 3? Why wasn't it just 2x plus 3? It's an excellent question, and the question comes from the fact that we didn't make you guys learn fractions all that well. Okay? So, if you have (4/8), you would tell me all day that that simplifies into what? Okay, right? Well, what if you had 4 over 4 times 2? Still 1/2. So when you do that, what you're actually doing is saying 4 divided by 4 equals what? 1. So you get 1 over 1 times 2. But no one really ever showed you that, and that's why you asked that good question. Does that make sense now? Okay? Okay. So now, here's what's new for today. They're called composite functions. And you'll notice them in today's assignment starting at number 9. Is that really loud? So, Sorry, I got them backwards. Oh gosh. Okay, so first today is the 10th. Let me show you how to say that. You say that G of F of 4. Okay? That's how you say it. G of F of 4. Okay? So in this problem, what is F of X? Jeff F of 4. Okay, that's true. All right, what's F of X? And what's G off? Okay, so here's what they want you to do. You always work right to left on these because of how it's spoken. G of F of 4. So what is F of 4? It's not 4x minus 2, it's 4 minus 2. You put in a 4 for the x, okay? And so what is F of 4? It's 2. Thank you, Jason. Okay? So, if you want to do G of F of 4, now you're just going to do G of, any guesses? That's right. You just take F of 4 and put it in for this input. And you get G of 2 is 2 squared. And so the answer is 4, okay? If you're into computer programming, this is a really important thing. Because here's essentially what's going on. You know how you guys hate these little machines that I'm always drawing? My little function machines? Okay? Here is what you're doing. Whoops. You're putting a number in. Some function is changing that number, spitting it out, and then the blue function is changing that result and spitting it out. And that happens in computers all the time. You have programs that are nested inside of programs. It's like the inception of math problems. Okay? Got it? So, let's do a couple more. Let's do number 10. That's how you do it. Okay? The answer to number 9, what was the answer? It was 4. It's just a number. Okay? So number 10, this says F of G of -1. So what do we do first? You do read it backwards. So you do G of -1 first. And I got to find these functions again. So that's going to be -1 squared, which is what? +1. So now what do? I put that in for F. So F of 1 is 1 minus 2. So that's -1. What was your question? Because this says F of G of 1. So first I did G of 1. I put 1 in for G. I'm sorry, I put 1 in for X in the G function. It popped me out a number. This number is G of 1. So if I want F of G of 1, then I take whatever I got for G of 1 and I put it in for X into the F function. Now, go ahead and turn it to the back. Number 15. Normally I would never do this, which is do the word problem for you. because I want you guys to do the word problem, but since this is our first word problem in so long, I'm going to make sure you guys do it right so that you understand that there is a point to this, okay? So, you got a car dealer. You got a 15% discount, and you have a $1,000 rebate, okay? So, part A says, write a function of x that represents the discount. You guys are not good enough at this. I wish we could spend more time making you better. If you get 15% off of something, then what percent of it are you paying for? 85. So, I don't know that you would be able to come up with this on your own, but hopefully you can very soon. F of x is 0.85. Where did I get that 0.85? 85% of x, where x represents the price of the truck. Is it a truck? Car. Okay? So that's A. B, I know you can get. So B says, find a function g of x that represents the rebate. Well, the rebate's a lot easier to do the math on. What do? You take the price of the truck and you subtract 1,000. Okay? So far, so good? All right. Now, C says, suppose the listing price of the car is $18,000. Use a composite function to find the price if the discount is applied. If the discount is applied before the rebate. So what are we applying first? The discount. So we will do 0.85 times 18,000, and what do you get for that? $15,300. And then what are we going to apply next? Then we're going to apply the rebate. Okay? So then I'll just write minus 1,000 equals $14,300. Okay? Now, I want you to know what you just did. You just did G of F of X. That's what part C was. Do you realize that? You did F of X first. Specifically, you did F of 18,000. F of 18,000 gave you 15,300. And then you took that number and subtracted 1,000. Well, that was G of 15,300, and 15,300 was F of 18,000. So while I understand this is very complicated, I think that situation makes more sense now, doesn't it? So now let's look at part D. What's the difference in part D? You're going to give the rebate first, right? So you'll do 18,000 and do what to the 18,000 first? Subtract 1,000, which equals 17,000. Then you'll take the 17,000 and multiply it by what? 0.85. Apply the discount. And what do you get for that? 14,450. And since the car dealer wants to make as much money as he can, he just wants you to think that he's giving you a great deal. Which way is the car dealer going to apply these two bonuses? He's going to apply the rebate first, because that gets him an extra $150. That's a Friday night for a car dealer because they're, you know. Why don't they? Because of the properties of algebra. Because not everything is associative. What associative, the question was, how come those two things don't equal the same thing? Because, like some things, the order doesn't matter. 5 plus 6 is the same thing as 6 plus 5. However, other things, the order does matter. 5 divided by 6 is not the same as 6 divided by 5. So those are called the associative properties and order of operations. And this is why people take math. So they can learn how to give themselves financial advantages. I mean, that's one of the reasons people want to be good at math. Okay? Yes. A rebate is something you get when you go to Menards. Essentially, a rebate is you have to purchase something and pay for it, and then you get this slip, and you send it in, and they send you a check back. It's really weird, but that's what a rebate is. I think it's because, like, Menards isn't taking that discount off, so Menards needs to collect their money. But let's say they were selling shovels, and the shovel company was giving rebates, so Menards collects the money, and then you send something to the shovel company that says, hey, I bought this shovel from Menards, and the shovel company's like, oh, okay, I'll give you an extra $3 back. It's quite annoying. Okay? Any other questions? Boom!